Here we're going to use this problem to show another ICE calculation, and then we're going to introduce what I call the quadratic shortcut. We've got the Ka for niacin, and we know the concentration of the niacin solution, and we want to find the pH. We're going to write this ionization equation. We don't actually have to know the formula for niacin in order to write it. Because we have a Ka value for niacin, we know that it is acting like a weak acid, so there will be H plus on the product side and one other thing, and that one other thing will have a 1 minus charge. So we don't actually have to know the formulas of these different things in order to successfully complete this problem. The initial concentration of niacin is of course 0.01 molar. The initial concentrations of the two things on the product side we're going to assume is 0. The niacin concentration will go down by some amount, and that will cause the hydrogen ion and the conjugate base concentrations to go up an equal amount. So at equilibrium, for niacin, we're going to have 0.01 minus X, and for H plus and the conjugate base, we're just going to have X, or 0 plus X, which simplifies to X. So now we're going to write the equilibrium constant expression for niacin, and as with all equilibrium constant expressions, the Ka is written products over reactants, so the two things in the products are both x's, so that's why we have x squared in the numerator. And in the denominator, we have the reactant term, which is 0.01 minus x. Now, if you look at this equilibrium constant expression that has the numbers and variables plugged in, you can see that that is a quadratic equation. And you would typically use the quadratic formula to solve for that. I assume you've been introduced to the quadratic formula, so I don't have time or the space on the slide to go through the use of the quadratic formula, but check it out for yourself if you want. If you use the quadratic formula to solve this quadratic equation, one of the values for x, the valid one, would turn out to be 3.92 times 10 to the negative 4th molar. And from that we can find the pH to be 3.41, which sounds about right because this is an acid and so the pH is less than 7, so this makes sense. Now, using quadratic formula to solve this thing, it's not difficult, it's just a lot of work. And there is a shortcut. If the power of k is negative 4, negative 5, negative 6, negative 7, and so on, if it's negative 3 or negative 2, don't use the shortcut that I'm going to introduce on the next slide. You will need to use the quadratic equation. But we're talking about the value of k. Look up here at the very top of the screen. See that power of 10? If that's negative 4 or negative 5 or negative 6 and so on in direction, then you can use the shortcut that I'm going to show you on the next slide. Now, don't write this down. If you're making any notes, don't bother rewriting this because this is exactly what appeared on the last screen. The shortcut will go something like this. Here's our Ka value, 1.6 times 10 to the negative 5th. There we have products. There we have reactants, just like we have on the previous slide. Here's the rationale behind the shortcut. If x is very small, then something minus x is very nearly the same as something. And of course, for those of you who are not native English speakers, this something here is my course abbreviation for something. Something minus x is very nearly the same as something if x is very small. So look in the denominator here. 0.01 minus something very, very small is essentially 0.01. That's the shortcut. Now, you can't do the shortcut on the numerator. You can't just say, oh, well, all the x's, just cross them all off. Then you have nothing to solve for. The shortcut involves this denominator in this case. 0.01 minus something very, very, very tiny is essentially 0.01. Now that is much easier to solve than using the quadratic equation. If you solve that, which will involve the use of your square root key, you will get this number, 4 times 10 to the negative fourth. On the previous slide, when we used the quadratic formula, we got 3.92 times 10 to the negative fourth. So this is a lot faster, and it's within 2 or 3%, so that's pretty good. And if we calculate the pH using the shortcut, we get 3.40, and on the previous slide, when we had used the quadratic formula, we got 3.41. So that's pretty darn good. So you can use the shortcut if the power of 10 starts with negative 4 or negative 5, negative 6, negative 7, negative 8. If it's negative 3 or negative 2, you can't use the shortcut.